Okay, here we go again. Going to cover u-substitution today, and then sometime soon implicit differentiation. And those are the two topics that a little bit different than what we've covered so far. And I'll be honest with you, I don't think there's anything else that isn't an offshoot of everything we've done so far. So just like we did bounded area today, we found the intersection of a couple of points and learned that the altitudes are the top function minus the bottom. That's all that was new. And the rest of it was just integration. So as you get stronger with integration and derivation, you can start doing more things, like a new topic, linear approximation. It's just derivation, write the equation with tangent line. So we've got chain rule now. And chain rule, y equals sine x squared, y prime is equal to the the cosine of x squared, right? Derivative of sine times 2x. We've been working on that. And a good number of you have already figured out how to do that, the mechanics of that. You'll be continuing to do it, so you're just going to get better at it. And the issue here is, how do we go backwards? How do we go in the inverse? Well, y prime is dy dx. You solve all equations by putting your variables together. So we're getting statements like that, which we've been analyzing at the start of class the last few days. Or at least I did with the Wednesday class. Going to do it with tomorrow's class, A, B, and C block. So we integrate both sides. And so you'd integrate cosine x squared times 2x. And hopefully you're seeing the chain here. This is called the argument of the function. Generally speaking, what we're about to do deals with the argument of the function, and you're going to get an adjustment needed. If this wasn't a 2, we're going to see that we need to make an adjustment for the numerics of this problem. The issue that I see with u-substitution is it comes at you with the 2x in front. Not a big deal. It's not a big deal, but it makes seeing the chain just a little bit harder. All right? And so let's get to it here in a moment, what we do to make this an easier problem. You've done some substitution and solving in your previous class. When we solved the sine of 3x equals root 3 over 2, we let 3x equal the symbol capital A. And then we solve for it. And for instance, A is, if we're looking at just in the circle, root 3 over 2 up here and up here. So angle A would equal pi over 3 or 2 pi over 3. And so then what did you do? You said, well, I know what A is. A is 3x. And you divide it by 3 to get pi over 9. Divided by 3 to get 2 pi over 9. And there might be more considerations in the unit circle. But that's the general idea for using a substitution, a simpler symbol for a more complicated one. And that's what we're going to do in these problems. So how would you go about and do something like integrating x to the 4th, I wrote a couple down, x to the 5th plus 1 to the 10th dx. Looks intimidating at the moment, but a week from now you probably do these with ease. Some of you might not even have to put marker to the board. All right, so what's the argument of the function? Well, the most complicated function is the 10th power here, and that's the argument of it. Okay, so that's x to the 5th plus 1. Now, might be better to write it this way for you at the start. Right? If you took the derivative of x to the 5th plus 1, you're getting something to the 4th power. You're definitely getting something to the 4th power. So where do we do the substitution? I don't know, if you're not seeing something, try rearranging and then look for the argument and something that connects to it in a chain way. All right, but textbooks and the YouTube videos that you might access to help you learn this skill, I'm going to present it to you that way. So we pick a U, a letter U is what's in the textbooks. How that was decided years ago, I don't know. And we'll let it equal x to the 5th plus 1. Then the intermediate step to get a derivative is differentials. So that changes by a 5x to the 4 process, dx. And therefore, if I isolate dx I get du over 5x to the fourth. All right. Now I'm ready for substitution. So instead of writing dx, I have a new name for dx. It may be called du over 5x to the fourth. Instead of saying x to the fifth plus 1, I have another substitution where I'm saying u to the 10. And this is x to the 4 still here. Well, I can see the x to the 4 is canceled. And I hope that by the time you see this video, we have done the problem, is the integral of 2x dx the same as 2 times the integral of x dx? I'm assuming that I've done that in class with you tomorrow. And the answer to that is, yes, it is. We looked at it pictorially. So these cancel, which means that I'm really multiplying this by 1/5, which means I can now bring it outside the integral sign. And that's the same thing as 1/5 u to the 10 du. Well, that's a piece of cake. That's u to the 11 over 11. I didn't leave myself much room for times 1/5 plus c. Well, I'm ready to write my answer now. It's 1/5. I know it, u is x to the 5 plus 1. And that's now to the 11th power, and it's being divided by 11 plus c. You're done. Oh God, I didn't leave. So I'll go through those steps again. I didn't adjust the camera properly. So, all right, I'm going to do the problem again. I'm not going to do the whole video again. I don't have time at the moment. All right, so let's just go from here. So we let u equal x to the 5th plus 1. Du, this is called the differential, is 5x to the 4th dx. And we've been looking at that at the start of class recently. That assigns slope values to some curve, this curve. Dx may be called du over 5x to the 4th. Therefore, I have two substitution statements, one here and one here. Okay, so I come back here and I write x to the 5th plus 1 by the first substitution, which is u to the 10 now. I'm substituting the letter u for that statement. So I'm using u instead of x to the 5 plus 1. Instead of dx, I'm going to write, instead of dx here, I'm going to write du over 5x to the 4. And I have an x to the 4 here. Okay, so the x to the 4 is canceled. And division by 5 is the same as multiplication by 1/5. Hopefully, as I stated earlier, you know that you can take constants out of an integral and it's still true. Hopefully we did prove it today in class. That's an easy integral to take. It's 1/5 times u to the 11 over 11 plus c. I can now replace u back with x to the 5. Let's make it smaller. X to the 5 plus 1 to the 11th power divided by 11 plus c, and you're basically done. You know, it's over 55, right? Clean it up a little bit. All right, so I'll do a couple more with you. We'll start doing them every day till the end of the term. We got a lot of the term done in the first 2 weeks here, which means we got a lot of time to practice stuff. So we've taken out a pretty big chunk. I don't even think BC Calculus is looking at integration yet. Maybe they've gotten there now, trimester model. I have to go and see. But these are basic integrations. We're not going to up the level too much. Just want to get what integration is, what derivation is, and if you come out of the course knowing that, you've learned something. All right, so let's see. You pause the video. You can try this. I'll get a better marker. X times the sine of x squared dx. See if you can figure out how to do that. Pause the video. I'll find a good marker and just keep going along here. Let's see if this baby works. Hey, that'll do fine. Can you see that? Oh yeah, you can see that well. All right, so I'll just do it now. Let's let u equal x squared. Then du equals 2x dx. Du over 2x equals dx. Substitution statement, substitution statement. As I come over here, x times the sine of u, du over 2x. Looks like the x's cancel, and I can take the 1/2 out. Integral sine of u, du is equal to, oh, I picked sine, huh? Negative cosine. I wish I had gone here with cosine instead, but that's all right. So this is equal to the negative cosine of u, right, plus c, and I'm going to multiply by 1/2, so I'm going to put the minus 1/2 right here, right now. Minus cosine u plus c. Okay, and so therefore, what is u? U is x squared. We're done. Now, if you took this derivative, you would do minus 1/2. Derivative of cosine is negative sine of x squared times 2x. And what would happen? You'd get minus times a minus, that cancels, becomes positive, and 1/2 of 2 is 1x. You're right back to the original question asked. Let's try another one. Let's try integrate 8x e to the 3x squared dx. Now again, if you're having trouble spotting the u at all, you might try integrate e to the 3x squared times 8x dx. Hopefully you can see that if you did the chain rule to e to the 3x squared, it's going to have something to do with x to the 1 in it. That if you did that, you would have e to the 3x squared times 6x. All right, so we're going to have to turn this 6 into an 8 with a little multiplication, a little conversion. And if you said 8 over 6, you'd be right. All right, so let's let u equal 3x squared. Then du equals 6x dx. And du over 6x equals dx. I now have two substitutions. Instead of dx, I'm going to say du over 6x. And instead of e to the 3x squared, I'm going to say e to the u. Oh, looks like the x's cancel. The x's cancel, and I can take an 8 over 6 out. What is the integral of e to the u du? E to the u plus c. What am I multiplying that by? 8/6, I'll call it 4/3. What is u in this case? 3x squared. And that was the original answer to 8x. I think I had 8x here, and I had 3x squared here, dx. How can we check if we're right? Take the derivative. What is the derivative of this? It is 4/3 e to the 3x squared times the derivative of 3x squared, which is 6x. What happens to 3 into 6? 2 times 4 gets us 8. Brings us back to that. There's an x, and there's an e to the 3x squared. So hopefully you can see that. Okay, maybe one more. Let's try one more. And then we'll just do them the rest of the year, the rest of the trimester. Okay, so you pause the video and you try it. What haven't I tried so far? How about we integrate 4x secant squared 2x squared. So let's go 10x squared dx. Okay, so u is 10x squared, and du over 20x equals dx. I skipped a step. I've got my substitutions now. I got 4x secant squared of u du over 20x. 4x divided by 20x is 1/5. The integral of secant squared u du. You haven't done secant squared a lot, but I know some of you know that's the tangent function. So we have the tangent of u times 1/5 plus c. And then at the very last step, you replace u again with what it represented, 10x squared. And you're done. Okay? First time you heard it, first time you've seen it, give yourself 3 or 4 days of practice. Let's see where you are after 3 or 4 days of practice. I know we're a heck of a lot better right now with approximating the square root of 25.1 than we were 3 days ago. At least the Wednesday class is. We practiced it several times, and I started to get some thumbs up and some facial recognition in class. So give yourself some practice here. Might do implicit differentiation before you hit the break for Christmas. And then when you come back, we'll just do those problems for, the worksheet with everything we've done for a week or so before we tackle anything new. I'm pretty confident at this point in time that we'll have 90% of the course done by midterm. First couple of days, you come back from midterm break. We'll do the 2 or 3 topics we haven't tackled, and then we'll just practice the heck out of it. Well, I guess I'm not even in the screen. Then we'll practice the heck out of it, and hopefully we'll be in good shape. A little tired. The old man's a little tired today. The eyes are drooping. Hopefully I had the video in a place where you could see everything. Honestly, now that I adjusted it, I hope that I haven't done problems that you couldn't see. If that's the case, just email me real quick. I'll make a new video. All righty. See you in class tomorrow.